Okay. I have something, little bits, I'm gonna try to keep this short, that I think is pretty cool. You know, just because you think about something logically, and if you can understand different factors, it doesn't mean that it's necessarily true. But it does allow you to think about, like, why might this happen? Why might this happen? Why might this not happen? And so we're going to think about that here with these inner four planets and our moon. You have to go explore and find out if your guess is right or wrong. Sometimes we're surprised and we're wrong, and sometimes we're validated and we're right. So I'm going to let you explore some of this, but consider, we talked about this. We're going to talk about these inner four planets. I've got Sun, and of course, the sizes of the planets are correct relatively, but Sun would be much, much larger. I've got Mercury there, I've got Venus, I've got Earth, and then I've got Mars over there, sitting up there, okay? And let's talk about the distances, and then we'll talk about sizes and so on. So remember that if Sun was a softball size, then these four planets would be like grains of sand of different sizes, but grains of sand. And how far away would they be in terms of distance? It would be about, you know, you could say four long steps. Take 4 long steps from your Sun, little grain of sand, 4 long steps out, and that's Mercury. Another 4 long steps out, who's next? Venus. Another 4 long steps out, that's Earth. Good enough, right? I mean, it doesn't have to be perfect, but that gives you a good sense. Little grains of sand, right? So that gives you a sense of the size, and you could see that. Another, not 4, but another 6 long steps out, and you'd be at Mars. Okay, so you get that sense. And of course, the light spreads out, and the solar wind spreads out. So it's going to get less bright out as you get far away, and the solar wind will be a little less intense. Well, we talked about Mercury, Venus, and Mars after we did Earth and Moon. We talked about Mars and said, hey, what happened with Mars with magnetism? And we talked about what happened with Mars, the water on the surface of Mars. What could have happened? Let's think it through. What could have happened in the last video? So here we have Sun, Mercury, Venus, Earth and Moon, and then Mars, okay, which has 2 little moons. And we said this, we said to have magnetism, we need to be warm enough inside to have some liquid iron, and we need to be spinning fast enough. 2 components we kind of look for. That's true of these metal inside, rock around it worlds, terrestrial worlds. It's different with the gas giants, but that's true of these, okay? So you're looking for 2 things, warm enough inside to have that liquid iron, and then a fast enough spin. And we've said Mars, I call it the world of 2s and halves, half as wide as Earth. So it stayed warm inside longer than Moon, and it likely had a liquid iron core longer than Moon. But it cooled, and so that liquid iron core could become more solid, right? Losing the liquid iron core. It's still got a good spin, right? 24 and a half hours spin, so it's spinning fast. The other ones spin slow. Mercury spins slowly, Venus spins slowly, a little bit the other way. Moon spins slowly, but these spin fast. Warm inside, giving liquid iron. Was warm inside, but consider this scenario. Suppose it was warm inside, releasing gas, had a liquid iron core, creating, with that spin, creating a magnetic field, deflecting that solar wind, right? But as it cooled, still spinning fast, maybe that liquid iron solidified. Maybe it lost its magnetic field. Then what happened? Well, maybe the solar wind stripped the atmosphere. And the water that we believe was about knee deep on Mars would then evaporate, as I demonstrated before. Okay. That kind of all connected, right? That's a reasonable scenario. So let's go to these other ones. I mean, you know what's up with Earth. Still spinning rapidly, 24 hours, still warm inside, still liquid iron core, has a magnetic field. The solar wind comes in. It gets deflected by that magnetic field, which is pretty darn weak, but it's strong enough to do this. And the solar wind, mostly protons, stream through at the atmosphere, the thin atmosphere near the poles, making that atmosphere glow in the ionosphere, creating aurora. Moon spins slow, small, doesn't have a liquid iron core to speak of, and so the solar wind just hits it, but there's no water to evaporate and no atmosphere. So what about these other guys? I think they're pretty interesting. So let's come over here and think about this. Okay, so Mercury. Mercury, being 1/3 as wide as Earth, you're going to say, well, that's cool inside. And it's spinning slowly, so you're not going to expect much magnetism. It's true, when Messenger went, there's more magnetism than expected. People explore that, but we're talking about 1% as strong as Earth's. So those are fine little points that people do in research, and they're interesting. But in essence, not much protection, right, with that magnetic field. So what's going to happen here? The solar wind's going to come in, right, and it's going to hit it and create a dust, and it's closer to the sun too. So create that dust and sort of create a tail. And of course, the side-facing sun is going to be lit. That's the day side. It's going to spin very slowly. The night side over here is going to be very cold, very hot, very cold. Hits the dust. The light and the solar wind come in past Mercury, and they say that there's a very cool light show over here. This is kind of like the aurora, but different, right? But still, it's that light and solar wind kicking up a dust, passing it over here, and making that glow from that light and solar wind on that side. So that's kind of cool. But no water on the surface to speak of, although maybe ice in the crystals. I say, well, what's going on with Venus? Still warm enough to have liquid iron inside, but we said no magnetism. Why? Could it be that very slow spin? Right? So no magnetism to speak of. And then you go, well, wait a minute. Mars lost its magnetism in our little story here and stripped some of the atmosphere, and as the atmosphere went away, the water evaporated. Why does Venus have the thickest atmosphere of these guys? Why does Venus have the thick? Why, if it doesn't have magnetism, why wouldn't the solar wind strip that atmosphere? And the reason is that Venus has that very thick atmosphere, and it's got a layer of ionosphere. Remember that top layer of atmosphere? That ionosphere actually interacts and deflects that solar wind. Because it's got a very thick and developed atmosphere, the solar wind doesn't interact with magnetism, but it interacts with the ionosphere of Venus. In fact, there's still a question as to whether there might be life, not so much on the surface of this dry, gray surface, volcanic surface world, but possibly some microorganisms that kind of flutter around, float a bit in the atmosphere. I mean, they do fall, but it may be such, there's this interaction, and it's cool. I'm not going to go into this whole thing, but there could be some microorganisms in that atmosphere. So it leads us to questions that we explore through exploration, spacecraft, taking measurements. So it's kind of cool, right? We think about where there could be microorganism life that could be sustained, where there could have been maybe more complex life. Certainly protecting from that solar wind is a good thing for us. And so we see these different factors. Mercury, no magnetism, not much. Solar wind hits it, deflects it. Here, no magnetism, and yet it's got a thick enough atmosphere, and that ionosphere will interact with the solar wind and protect that and not strip the atmosphere. You know what's up with Earth. And then Mars, where is it cooled? Possibly the solar wind stripping, thinning its atmosphere and evaporating the water. That's kind of a fun way to think about that and to tie that together and to consider that. And in the end, you gotta go look and check what people said, check what people find out, and always stay alert to new findings.